Alrighty, so we have video notes here for section 8.2. At the top is kind of a little of a warm-up to get you started. So I'll start you out on number 1, but I'm going to have you do number 2 and 3. We'll check those in class next time. So number 1, just to review, if we have 2 to the x, and I want to graph this, I'm going to kind of in my head go through a table. So if I plug in -1, for x, then I would get 2 to the -1 is 1/2. If I plug in 0, I would get 1. If I plug in 2 to the first power, I would get 2. So it's kind of going up like this. It levels off as it goes to the left, but keeps going up to the right. So there's my graph. The asymptote, the line that it cannot hit, happens at y = 0. The domain is going to be all the values of x, so from -infinity to +infinity. And the range are going to be only those positive y values, so everything from 0 to +infinity. Alright, you need to do numbers 2 and 3 of that warm-up. Pause the video. Once you have those done, unpause the video and we'll get started on the next problem. We will be checking over those in class. Okay. So we're going to see what these different things do to our exponential function and start playing around with it a little bit. So let's look at that a that goes in front. Let's start by graphing these 3 equations on the same graph. So for my first, y = 2 to the x, it's nice to make a table. My x, y, we'll just plug in -1, 0, and 1. If I plug in -1, I get 1/2. 0, I get 1. 1, I get 2. So let's make a table for x and y. For our second function, y = 3 times 2 to the x. So I'm just going to multiply each of these values here by 3. It's the same function, but times 3 in the front. So for -1, 0, 1, I get 3 over 2. 3, and 2 times 3 is 6. For my third function, I took 2 to the x and multiplied it by -3. So I'm going to take these values here. 1/2 times -3 gives me -3 over 2. For x = 0, I have 1 times -3 is -3. And for x = 1, I have 2 times -3 is -6. So this is going to help me in graphing my problem. So I need to graph each one of these. So the first one, I'm going to use a dotted line to graph. So I'm at -1, 1/2, 0, 1, and 1, 2. This is my parent function, just a number to the value of x. So it looks something like this. My second function, y = 3 times 2 to the x. Let's graph it. We have 1, 3 over 2, or 1/2. We have 0, 3, and 1, 6. So he's going to look more like this. And our last function, -3 times 2 to the x. We have -1, -3 over 2, 0, -3, and 1, -6. So he's going to look like this. So what did that a value in front do to our parent function? If a was greater than 1, so like in 3 times 2 to the x, we're calling that a vertical stretch. So it takes the graph and it kind of stretches it out vertically. Okay, it's making it bigger, like you're pulling it up. If a is between 0 and 1, then it's going to do the opposite. So we're going to call it a vertical shrink. It's going to squish it down. So think of it as you're flattening the graph, shrinking it down. And if a is negative, like in our last function here, we saw that -3, it flips our second function over the x-axis. Alrighty, let's try an example. Let's graph the equation y = -2 times 3 to the x. So let's start by using the parent function, which would be 3 to the x. So let's make our table here. and then we'll put in what our final values for y will be. So if I plug in -1, 0, and 1, if I plug in -1, I get 1/3, 0, I get 1, and 1, I get 3. But I have that -2 in front, so multiply each of those by -2. I get -2/3, -2, and -6. So if I graph this guy, I can graph my parent function is at 1/3, 1, and 3. So he looks something like this. My new function is going to be at -2/3, -2, and -6. So he's down here. So you should notice two things, that this graph is flipped over the x-axis, but it's also been stretched. It's made longer in the vertical or y direction. Now looking at our graph, we can still find our asymptote, domain, and range. So our asymptote, this one, it's getting closer and closer to 0, even though it's coming from the opposite direction. Our asymptote is still y = 0. Our domain is still going to be all the reals for x. So we're going to put -infinity to +infinity. And our range here is everything less than y = 0. So we start at -infinity and go up to 0. So our minimum to our maximum. Alrighty. Make sure you have everything on this page and turn to the next. So we're going to start with our standard form of an exponential function. We already talked about y = a times b to the x. We're going to add a little bit to this and say y = a times b to the x minus h. And on the end, we're going to put plus k. And talk about what it could look like if we have some other things going on in our function. So let's see what happens when we graph this. If I graph y = 2 to the x, and then we're going to do y = 2 to the x minus 3. So let's make our table. X, I'm going to do 2 to the x, and then I'll do 2 to the x minus 3. And we're going to need a little bit more room on this table. So write kind of small. Start with -1. Then I would get 1/2. And for 2 to the x minus 3, then that would give me 2 to the -4, which would be 1/2 to the 4th, which is 16. Let's try plugging in 0. I get 2 to the 0 is 1. 2 to the 0 minus 3 would be 2 to the -3, which is 1/8. Keep going. Let's plug in 1. 2 to the 1 is 2. 2 to the 1 minus 3, that's 2 to the -2, is 1/4. If I plug in 2, I get 2 squared is 4. 2 to the 2 minus 3, which is 2 to the -1, would be 1/2. Let's try plugging in 3. I get 2 to the 3rd power is 8. 2 to the 3 minus 3 is 2 to the 0, which is 1. And let's do one more. If I plug in 4, I get 2 to the 4th is 16. 2 to the 4 minus 3 is 2 to the 1, which is 2. So you should notice our values here look real similar to our values here. Let's see what this looks like on the graph. If I graph just y = 2 to the x, at -1 I have 1/2, 0 I have 1, 1 I have 2, and we'll keep going. Then I have 4 and 8. That should be enough. Let's graph this with a dotted line. This is our parent function. And now let's graph our new function y = 2 to the x minus 3. So at -1, I have a y value of 1/16, really tiny. Then I have 1/8, also tiny, 1/4. At 2, I have 1/2. At 3, I have 1. And at x = 4, I finally have y = 2. So he's going to look more like this guy. So you should start to see that we've kind of just shifted our graph over. So what does h do to the parent function? If we have y minus h, we're going to, just like in our example above, we're going to shift right. Whereas if we have x plus h, we're going to shift left. Shift left. Okay, so remember, what's inside parentheses lies. H is a liar. It's the opposite of what it seems. Let's go ahead and put our asymptote, domain, and range in this problem. Our asymptote is still y equals 0. We never crossed that x-axis. The domain is going to be all the x values from negative infinity to positive infinity. And the range is all the positives, so from 0 to positive infinity. Alright, we have one more thing to look at, which is our k. What does k do? So let's start with our graph, or our table, I'm sorry. We're going to do x, then let's see what our parent function 2 to the x looks like, and then we'll do 2 to the x minus 4. And since we already did 2 to the x above, we can borrow those values. Okay, so I have, if I start at negative 1 for x, I get 1/2, 1, 2, 4, 8, and 16. And I'm just stealing those from my table above since we're dealing with the same parent function. And now I'm taking 2 to the x minus 4 for my new function. So I'm just going to take each of these values and subtract 4. So 1/2 minus 4 is negative 3.5. 1 minus 4 is negative 3. 2 minus 4 is negative 2. 4 minus 4 is 0. And we get 4 and 12. So on. So when we graph this guy, let's graph our parent, which is at negative 1, 1/2, 0, 1, 1, 2, and let's do one more. We have 2, 4. So here's my parent. And let's graph our new function, which is at negative 1, negative 3.5, 0, negative 3, 1, negative 2, and 2, 0. So here is my new function. Okay. You should notice that this new graph is still kind of leveling off as we go to the left. The difference between the values keeps getting smaller, so it's still going to level off. Our asymptote is going to change in this problem. Okay, it's not going to be the same. So let's look at first, what does k do to the parent function? Okay, it took our parent function and it shifted it down. So if we have a positive k, we're going to shift up, and a negative k, we shift down. So since we're shifting up and down, that's going to affect our asymptote. In this case, we shifted down 4, so our asymptote is also going to be down 4 at the line y equals negative 4. So if I draw the line at y equals negative 4, my graph is going to keep getting closer and closer as I go to the left, but it's never actually going to touch that. I'm never going to get a y value of negative 4. My domain will still be all the reals from negative infinity to positive infinity. And my range is now going to be all the y values above this line, which was y equals negative 4. So my minimum is going up to negative 4, anything above negative 4, but not including, so use parentheses, and going up to infinity. Alright, so we've looked at what our A in front does, our stretches and our shrinks, what our H can do, and what our K can do. So we looked at our shifts as well as our stretch and shrink. We'll talk next time in class about putting all of these things together in one graph.